Hello, everybody, and welcome to Sparing Partners. This is, again, another interesting podcast where we talk about antennas. Antennas used to be a kind of boring bit, if I must say so, of the network. They're just doing their own thing, passive, sitting out there. But they're becoming increasingly intelligent and playing a much more active part in the network, and they do so because they can optimize the way the network works. And so there is this big transformation going on, and I am very pleased to have Aleksis Anterow to talk to us today. He is the CMO at the Huawei Antenna Business Unit, and he's based in Munich. So, Alex, why don't you tell us who you are and what you do to get started?
Sure, Monica. So I'm a Swedish guy. I'm older than I look. I've been 3 decades in this industry. And since my very start, my career has been spinning around boring topics like antennas and RF. For a nerd like me, it's not boring. And one thing that makes it exciting is that even though it's an old topic, and maybe even a traditional topic, it has been going through a lot of quite drastic changes and revisions over all these years and all the iterations from a network architecture evolutionary step. And right now, what is really exciting me is the fact that I see more and more signals from the industry that antenna is becoming part of the network intelligence layer stack. And that leads to certain changes in the industry, a shift that, for me, as a change-oriented guy, it's very energizing. So despite it's an old technology, I think it's super exciting to be in antennas right now.
So maybe since you've been in the field for quite some time, maybe you can give us a sort of like a high-level view of what's the evolution with antennas.
Right. So first of all, you might ask yourself, why is antennas actually needed? Why are they so important in a network? And as a young engineer, when I started, there was a small French company I very quickly get in contact with. And they had this, to me, inspiring vision, making the invisible visible. Because antennas is like an invisible glue that makes it possible to have wireless connections. They connect the networks, the base stations with the users, the smartphones, and the people on the move, like an invisible layer, you can call it. And I always found it very exciting how a simple mechanical component could have this effect in invisibly connecting the world. And I think what we are facing right now in the industry is a dilemma, because antennas have always been and are invisible also for the operator or for the network. They are like static black box, a mechanical component that are installed, and then they are invisible for the operator for the rest of the life cycle. And with digitalization, the industry aimed to change this, to make antennas visible in real time, remotely. And since antennas, now I'm talking a lot here, since antennas have the function to connect the digital with the physical world, they are like the hands reaching out and grabbing the physical world. But it's useless if you don't have the eyes, so you cannot see where you're reaching out to grab something. And the second thing with antennas, through this shift to make antennas part of the intelligence stack, is that they need to be dynamic instead of static, something that can in real time shift. So you can reach and grab, connect to the users where they are, where it makes sense, or correct mistakes. You were thinking you were reaching here, but you reached there instead. So making antennas visible and remotely controllable, that's a huge shift for the whole industry, for the entire ecosystem. And this is kind of a transformation phase, you might call it. We are in the earliest stages at right now.
Yeah, and so it looks like, it used to be that you go, you install your antenna, you forget about it.
Right.
Becomes invisible. So it's very visible when
Exactly.
you install it, and then you say, well, we're done. And
Yeah.
right now with digitalization, this paradigm is flipped. In a sense, you still need to install it properly, obviously.
Yeah, sure.
But then you want to constantly keep track of how they're doing and then change accordingly. So let's just think about the first step is you need to know if your antenna is not installed, it's not pointing in the right place, basically.
Right.
Well, you want to change it, but before you do that, you need to know what's potentially wrong. So you need to have a good information. Do we have that information about the antennas?
Do we have that information? It's kind of a leading question. In a way, you might argue that it's a beauty in simplicity that antennas are agnostic to technology. You install, set, and forget it. There's a beauty to the simplicity. But it doesn't work in the modern world where operators want to automate the network. Automation not only to save manpower, but to make network more agile, faster, and more optimized. And to do that, you need an accurate digital twin. The digital twin is for the operator a digital model of what a real physical world looks like. You have the map, which is like the operator plans in ATOL or whatever tools they utilize. They configure all the sites. Then you have the real world. And there is always a difference between, let's say, the replica, the digital replica, which is the model that operators base all optimization on, and the real world. Location are sometimes wrong. For example, I was in Paris meeting one of the big operators recently, and they told me that in the planning tools, all the buildings in Paris are like simple rectangular boxes. They can put antennas in the corners they want it. And in reality, when operators, installers go there, they find out that the roof looks like this. They have maybe a free spot on another side of the building. So there is a difference in location very often. And then there is also a difference in where the antennas are pointing for several reasons. If you take, let's say, a life cycle perspective of antennas in Europe typically stay around 7 years, plus minus a couple of years. So antennas installed before COVID, they are still operational and expected to keep working. And many things can change. Even from the point of installation, installers, the guys who install the base station sites and antennas, they are measured primarily on how fast can they do it. Sometimes they have expensive accurate tools. Most often they don't have it. So there's in reality always an error where the antennas are pointing. Not because people are sloppy, but they don't have the time and the tools to do it accurately enough. In Europe, the average error is something like 14 degrees or so, and that's quite a lot regarding where you have coverage and where you actually don't have coverage. Some people might have a blind spot. Maybe you have noticed when you have traveled around that sometimes it comes and goes a little bit. So installation error is one thing. And then over the time, there are two kinds of shifts in a network that makes antennas not point in the ideal direction. And one is, let's say, a slow moving shift, a slow cycle shift. Because during all these years, antennas are installed, maybe new buildings are popping up, maybe even a new shopping center, maybe a new bus stop or even a metro station, maybe the routes shift a little bit. So the real physical world, the environment, might look different several years after the network was planned and installed. The second shift is a fast shift that might shift maybe several times during a single day, or maybe even more frequently. And one example is from China. Everything is big in China, and university campuses are huge. One campus is like a small European town, basically, with double-digit base station sites. And this is very tough for the big operators, China Mobile and company, to plan with, because suddenly you have a very high concentration of students in one spot. When they are registering, everyone is scanning QR codes, want to upload on the social media, and now we're starting. And at another point of time, they might be in a lecture, or they might be in the, let's say, dormitory for the evening, etc. So it really always fluctuates. And the dilemma for operators with these fast moves is they're doing a static planning supposed to be optimum for years, while reality is shifting faster and faster in when and where and how people are using the services. So the ability to be able to remotely monitor where antennas are, how they are pointing, and even add the possibility to control them remotely, that unlocks optimization possibilities for operators. all networks are performing on a lower level than they could do theoretically. And there is one thing operators, at least in my experience, especially here in Europe, where it's very tough to get permissions for installing new sites, for example, site approvals, it's very expensive and so on. They want to squeeze out all the value they can of every single physical site they have already. So this is essentially a way for the operators to start closing the gap between the real network performance and how it theoretically could perform with the assets they already have, the number of sites, spectrum, the radio boxes, the MIMO configurations. So you could argue it's a low-hanging fruit for the operators without massive investment, squeeze more value or get better user experience from their network. So I think the time is very good right now to talk about this shift in antennas, because automation is a key strategy for operators. User experience is king for all the operators. So all the vectors are kind of pointing in that direction right now to take this shift from something all the very static, invisible, to something dynamic, modern, real-time, remote controllable.
So couldn't you just say, well, let me play devil's advocate here. Just use massive MIMO beamforming, and that is a way to do more dynamic.
Mm-hmm. Yeah, massive MIMO is, of course, a very good example on where antennas have been digitalized to a large degree. A lot of the magic happens in the baseband in the massive MIMO. The antenna structure is actually relatively simple, and then the magic happens in the baseband, how to do the beamforming weights, algorithms, etc. So you can say that with the massive MIMO, you have taken a big step forward to digitalize antennas, but still, let's say, the visibility, the telemetry from the physical sites goes through the baseband numbers to the RF counters. So it's indirect parameters still. So even in the case of massive MIMO, I would claim that operators don't have the full visibility into the, let's say, the radiation layer in the stack. The telemetry, the ground truth is still not as high as it could be. A good step forward, but with this antenna digitalization, it's something much more than adding sensors in the antennas. I think it's more like an architectural shift for the industry, where all the layers traditionally, except for the antenna layer, has been part of the digital stack. And now it's like an architecture where we are bringing the antennas into the digital stack and making, through the ground truth, making sure that the basics are in place for all optimization through automation, having the accurate parameters for the physical site. And that is applicable both for massive MIMO as well as for passive antennas.
Yeah, and I guess that this is important to understand that it's on top of it. So there are different levels in which you can optimize, and obviously, so if you have your massive MIMO pointing the wrong place, well, you're still not doing well, even though massive MIMO can, help you. So what is that we need to do in order to establish what you call ground truth, which I think it's a beautiful expression for what it is. So because you'd think you have the antennas out there, obviously you know where it is, what it does, but it's not like that. What is that you need to do in order to?
Sorry, it's not what I missed the word you used. Antennas is not.
I forgot what I said. Okay, let me start this all over again.
Okay.
And, okay, hold on here. Okay, so I forgot what I was asking. You see, so you have these antennas out there, and you mentioned ground truth, which is a beautiful expression to see, what is that the antenna is doing, what is it pointing, what is the the band out there, and how is it that we need to know? What is that we need to know in order to optimize, and how do we get to that data?
Oh, okay.
Operators don't have that data.
Yeah, sure. I like to think it in terms of, like, to use the terminology from DevOps, instrumentation of the radiation layer in the networks, meaning that the operators can be confident that they have the accurate, very precise, correct data in real time for what the physical world looks like from, let's say, a coverage perspective. Antennas are fundamental for operators. They provide coverage. They provide, let's say, the maximum limit for the throughput, interference control, MIMO channels availability, and user experience last but not least. So it would be very strange to have all the software running with automation, but not including this physical layer that determines, let's say, the baseline for the whole network performance. And maybe I can give you one example from when I met an operator, one of the big global operators in France recently. And they told me the example related to how they optimize or maybe not optimize a network. And they gave me the example that they sometimes suspect that a site is not performing as well as it could if they look at the KPIs for the site, maybe even user feedback. Or the network planners think if they look into the data that they could make some changes in order to optimize the performance. But if there is one thing operators are very worried about doing is touching the network and degrading the performance. That's unacceptable for any operator. Any change needs to lead to an improvement, and degradation is unacceptable. And they told me very clearly that the fact that they don't trust, they know that our errors, they have assumptions that are not correct between the plan and the real life. They don't dare to change and adjust things for the simple reason they know that it might get better according to the plan, but it all might also degrade it if the reality was different compared to the plan. So they are afraid to touch the physical sites. It blocks the optimization. So the fundament to introduce a larger scale optimization of RAN in networks is that operators trust the data in the digital twin, the ground truth, or whatever you like to call it. Accuracy needs to be there. Trustworthy data is the fundament for all optimization, especially automation when you let the machines run on their own to adjust things. You asked about what do we need to do this. And one thing that antennas need to be enabled with, and now I'm talking like an industry movement, the whole ecosystem, is to have the possibility to remotely provide very accurate position and orientation data. This can be done by having, for example, satellite receivers with very high precision, GNSS receivers in the top of the antenna, having 2 of those. And then you can provide with special techniques utilized in high precision GPS positioning, etc. Very, very precise position data, more precise than the most precise installation tools used by installers. So that's one thing to, let's say, from a feature functionality perspective, equip antennas with it. The second thing you need to do is to recognize that great accuracy in lab, where you have, let's say, you have full visibility to the upper hemisphere, you can see all the potential satellites in the current constellation. That's one thing. But reality is a very different thing. From antennas, they might be next to a big wall from a huge building. Then need maybe other antennas or microwave links or boxes above the antenna. Antenna might be under, let's say, a metallized balcony or whatever. And another operator, one of the big global operators in Europe, who has made it very public that they see the network as a sensor, they are, of course, exploring this direction for antennas. And they told me very clearly that in order for us to roll out this functionality, it's super critical that we can trust the precision, the accuracy of such data. Otherwise, the opcos or the planners or the tools wouldn't trust it. So having the function is one thing, and secondly, making sure that it really works, not in theoretical best case, but in real cases where there's a lot of blockage, equipment, and things that are not ideal. Those 2 things need to be in place.
So when you think, when you look at it, it's like, okay, so you need to have better data, but we do have the technology to do that. So it's just a question of implementing all the basics. Okay, now let's say that the operator you were talking about has all the data. How does it go to optimize it? Because there is a new building coming up. There is the trees build new branches or have more leaves in the spring. Then the students move around through the day. So there is different time resolutions where you can optimize at different time scales,
Yeah.
right? So how should we think about that?
I think it is basically a matter of having closed loop automation in place. Currently, I would claim that automation is open loop when it comes to connecting the physical world. There is no feedback system in place. And with this, it's possible to close the loop to get this real feedback from the sites. And I gave this example with a university campus, but another case that is maybe unfortunately, but also becoming important in Europe is something called network resilience. That means that operators, they kind of have an obligation. Maybe they don't get extra revenue, more subscribers from it, but they have an obligation to the society to make it possible for people to pick up the phone and make a call if there is an emergency or a hurricane or something. And it's very bad if the network stops working, which often is the case because due to strong winds, antennas might lose the orientation. Or like we had in Spain, I think it was 2 years ago, a big energy outage. So operators needed to start switching off layer by layer, starting with a massive MIMO and then working downwards to provide this kind of recovery very fast. And this is one example on what could be done by this closed loop, so that the antenna system, the system in the software can alert through a trigger signal, for example, that now some things are not okay. Now something needs to be changed. And then it can be done manually or through automation. So simply closing the loop and providing this awareness about what is the state in the run layer opens up this possibility, because manpower is expensive. It's very time consuming to send people on site. So operators typically don't go out and check when they suspect that something is wrong. It needs to be maybe really bad. KPIs start dropping or a lot of customer complaints. But it's too expensive to go out and check after a storm, for example. And with this telemetry in place, it's possible to very precisely, with surgical precision, get alerts. Now something is not good here. We need to change something. We need to optimize something. And then if you combine that with the possibility to remotely send commands, this could be a matter of the software operating system run by the operator. Send a command that changed the orientation of this antenna, or now we lost that site, now you need to provide basic coverage from another site. Things like this. It opens up this closed loop feedback for the digital twin, for the actual situation, and acting like, as I mentioned in the start, the arm that can reach out and solve the situation remotely. It's maybe not rocket science.
You're basically going into having a real-time control over the antenna, and then you just decide what your parameters are and say, okay, you know, now that is for each antenna in your own network. So that's a lot of work. And so you do need both automation and the AI. That right? So are we ready to do it now, or is it just still trial phase?
First of all, it's already starting to happen. And I'm old enough to know that from, let's say, idea to making it real, typically takes longer time. People say that things typically take longer time than you anticipate, but then have a bigger effect than you expect. But in this case, I've been very surprised, if I may say so myself, on how fast this has been picked up, not only in China, but in all parts of the world. Latin America, Africa, Middle East, Asia Pacific, and also here in Europe, from the very Nordic countries to the very south of Europe. So it's really happening, that is for sure. Second thing, I forgot what you asked, the second thing. Is it really happening? And then you asked something.
Yeah. Well, is it just trial phase right now, or do we have commercial deployments?
Oh, yeah. You asked about, do we need to wait for full AI and everything? And
yeah.
I think it's kind of a matter of choice from the operator. Either it's a possibility to keep working manual before, like manual planning, manual installation, manual optimization, manual sending people on site. The difference is, even though it's done manually, you have high precision data. You only need to send people on site when you are sure that you need to change something on site. So it can, even for the fully manual optimizing. And then I think it's a ladder where you can climb step by step towards full automation. It's a buzzword, fully automated network, autonomous levels, etc. I think it's up to each operator. How do they want to move? How fast they want to move? I see it more like a hardware platform that enables operators decide themselves how much automation do they want, how fast do they move. And one of the beauties with passive antennas, it's agnostic. So in principle, I'm all in favor of open ecosystems. So they still have some kind of flexibility working with only one vendor, maybe with a third-party software or a mix of vendors. It's very agnostic. So the operator has a lot of choice. So reality is driven not by us speaking coming from a vendor, but more like the operators. What visions do they have and how do they want to move forward? And frankly speaking, I think maybe the big elephant in the room is maybe more the human element rather than the practical tools and techniques available in software platforms, etc., that determines this. But that's maybe a different discussion.
Yeah, but you're absolutely right. And before you were talking about operators being very careful about making changes because they can deliver something worse performance. There is clearly the human element because as a human in charge of making that decision, if things go well, you probably are less rewarded than penalized if things go badly. So
exactly.
It's not an even thing. So that is something that we should always, keep in mind. But you mentioned before that the lifespan of an antenna is 5-7 years. So in that case, do operators need to wait until they have an antenna refresh, or can they just automate and make the current antennas digital? So what I mean is, do they need to change?
Yeah, I see your point there. And it's not such an easy question to answer, actually, because of course, obviously, operators want to protect the assets in their books, want to maximize the lifespan, only swap if things are strictly needed. On the other hand, since it's a fact that passive or antenna lifespan is long in the network, operators know that the decisions they do today kind of needs to be useful, productive, competitive for many, many years in the network. So operators are in a situation that even if they are not strictly needing the things right now, they need to think maybe one or several steps into the future because they are today building the platform that will be valid beyond 2030 in their network. So they need to anticipate on what functionalities, what experiences do the physical sites need to support. So they need to have, let's say, a clear vision where they want to go. Automation, optimization, etc., and then making sure that investment decisions they take today point in the right direction. And then you asked about, but will they actually take down an antenna that is fully functional? Maybe that's a tough shot for the operators. Maybe that's not realistic. On the other hand, operators have cases where they can claim that it's very inefficient to have the current static solution. Let's say, use case based, there are cases where it makes a lot of sense to upgrade antennas. Other cases is more a matter of making sure that the sites are future protected so that they can have a long, smooth lifespan. Because I come from the hardware world myself, but software guys, they always claim that we would like to have as stable hardware as possible. We want to have a stable platform to develop against so we don't have to introduce unnecessarily changes and complexity. So from a network simplification perspective, it's much better for the operators to have, let's say, the same functionality everywhere. Instead of having to go out and check, did we implement that feature there? Yes or no? And then it starts fragmenting the world from a software developers and automation perspective. So it's hard to predict the future, of course, and I need to be realistic. But I start to see signs that some of the big operators, they are taking steps to provide, let's say, a baseline requirement for antennas to have maybe not all, but certain levels of digital functionalities in the antennas in order to provide this common baseline for the operations, even across OpCos, even across multiple countries, so that they know that if we develop a certain software automation, or if we implement a new working practice, we know that it can work in multiple sites. and we don't have to be very selective because that would get too complex. So
Oh.
a long answer shows maybe that there is no simple answer to this question. How to
So they
move
need,
forward,
they
how
need to, they
fast and
need to
where.
think, they need to think it through.
Yeah.
And it makes sense. Now, an antenna is not a thing on its own. It exists in a network, right?
Yeah.
So if I optimize antenna number one, then there is the antenna number two
Yeah.
next to it that might
Yeah.
need to be changed because of what you move one and then you should be
Yeah,
optimizing
exactly.
the other and then you go back. So you kind of can go back and forth. I mean, this is just two,
Mm-hmm.
but obviously there is many of them
Yeah.
in the network. So how is digitalization going to address the issue that you have multiple antennas? Do you optimize across all of them at the same time, or do you optimize each one of them?
From a network optimization perspective, this what you bring up is actually a very good example, because it's exactly you say, it's a puzzle with a lot of dependencies. Change one thing, it impacts on multiple other things. And if you change the other part, it goes back and change the first thing that you touched. And this is very hard for network planners to do manually. They have only a limited physical cluster that they can overview. It gets too complex to optimize wider areas. At the same time, as in my opinion, you very correctly pointed out, to really lift the network performance, you need to see it like a large scale optimization across clusters. The wider areas you optimize it, the bigger benefit you can gain. But in reality, it requires, it's actually a perfect case for AI. Have this big data, a lot of dependencies, complexities, where it might only be noise or too complex for manual work, but through AI, it can lift the level quite rapidly, actually. I'm getting into details, but we had a case recently in China where China Mobile had some, let's say, competitive challenges versus other operators in Beijing with coverage. And then they applied on a large area this optimization of a large cluster, and was able, through by making tiny small changes here and there, really lift the coverage, close the gaps, which shows that there is something to be gained from doing it in large areas. Smaller areas, like small case, that's more like special scenarios. Let's say you have a stadium event, you want to shift from outdoors to inside the stadium, etc. But for, let's say, the normal macro sites, the mobile data for people on the street, then the wider the area, the bigger the benefits, basically.
Yeah, absolutely. And so that I think it's quite interesting. And then again, you need to be able to manage a lot of data, a lot of sites at the same time. And to think you have humans doing it, you just need huge number of them, and then the cost will be so high that it's not worth it if you have to pay so many people to do it. Now, another thing that when you have antennas not pointing properly, just obviously they're not efficient, but there's also some other issues. And so as we move to areas where we have drones sensing that require much better knowledge about what's going on out there, don't we need antenna digitalization to support that, in the sense that you need to have establish the ground truth to know exactly what the data from antennas coming back to the operator is it reliable or not? So you need to have a different level of trust in the data you're getting from the antennas to support those services.
Yeah, I guess what we are talking about now is more sensors, which is a very trendy topic, especially talking about 6G, combining communication and sensing. And one of the real assets the operators has is that the physical sites is like the nervous system in the body. They have like an asset that they have a continuous physical presence across a full country or even a continent. And it provides like the perfect grid for equipping the physical world with sensors, whether it's ambient data, whether it's camera or infrared sensing, whether it's drone towards the sky or whatever. So I think maybe it's a bit old-fashioned to think about a physical site for an operator as like the power and the data communication, and that's it. Maybe there needs to be a shift to considering physical sites like a sensor hub in the network, where it will be very smooth, very natural for operators to complement, for example, antennas with additional sensory data to support future use cases like how do we manage drones towards the sky or whatever. Imagination is kind of the limit. The idea is maybe not so new, but the hard part in the past was always how can we monetize this? Great idea, but where does the revenue come from? So I think, frankly speaking, moving forward, I think it's a matter of combining the technical building blocks, which starts to be there. With antenna digitalization, it's starting to become natural that the physical side provides input to the network, ground truth or ambient data, or whatever. If that could be combined with some use case, for example, in 6G visions or low altitude economy drones or whatever, then maybe we can combine the technical dimension with the business dimension to something operational. And then for operators to leverage the value of being physically present across wide geographical areas. So your idea, I think, is good. We need to
Well,
see how fast it can fly and what are the winning use cases. That's hard to predict as always.
If you combine different use cases for the same thing, then it makes it more appealing, because oftentimes you just say, well,
sure.
is this monetize allow us to monetize something, but
Yeah.
if whatever you try to do opens multiple opportunities, it's
sure.
easier to make a case. Anyway, Aleksis, our time is up, but I think that this is something that we really need to keep looking on, and maybe we'll talk in a little bit to see how much progress is there, because that seems like it's so compelling to as we move to AI implementations, we just can get it everywhere and improve every little bit of the network.
Yeah,
so that's so incredibly exciting. So thank you so much for sharing your thoughts with us today.
Thanks a lot for the talk, Monica. Always nice to talk with you.
Thank you, and thank you all for listening in. And if you do like Sparing Partners and enjoy it, let your friends know about it as well. Thank you.
Thank you.